is Dr. Terry Schulze of the New Jersey State Department of Health. As way of introduction, Dr. Schulze has been working with the ecology and control of both Lyme disease and the tick, Ixodes damani, for many, many years. In fact, we were colleagues in graduate school when we both attended Rutgers, and I had the chance to leave a year before he did, and I still am miffed as to how he continued without me helping him along. But nonetheless, he's been working with this disease and the tick for about the last 10 years or so, and has methodologies developed to control the tick. So he'll be addressing us on the ecology and control measures for Ixodes damani. Terry.
Thank you, Ed. I managed quite well, thank you. Can I have the slide? Okay. You didn't think you were going to get away without moving around again, did you? For the next hour or so, I want to spend talking about how really to control this tick. I'm sure you all know now that this is a tick-mediated disease. It's transmitted primarily through the bite of infected deer ticks, shown here as a family portrait. To the left is the larval tick. It's six-legged. Next is the nymph. In the center of the slide is the female, which has a dark shield-like portion behind the mouth parts called the scutum, and in real life that abdomen is a brick red in color. It's a very distinctive tick. All the way to the right-hand side is the male. You've undoubtedly heard that this species is quite small, and while it is indeed smaller than most of the other medically important ticks, at least around here, all subadult stages of ticks are proportionately small. This is a three-host tick, meaning it must locate and feed upon a host 3 times to complete its approximately 2-year life cycle. If we start out in the fall of the year, both male and female will locate a host, usually a larger animal for reasons I'll talk about in a while. These ticks are not host-specific, that given the opportunity, they will feed on most anything. The female will take a blood meal and mate while on the host, remain on the host throughout the winter, drop off the following spring, digest the blood, lay a batch of eggs ranging from 100 to 200, from 1,000 to 2,000 eggs. Those eggs will mature and hatch the following summer. We're just about to the point now where we can see larval ticks on mice. The peak, at least in New Jersey, is the 3rd week in July, and Dr. Boster tells me you start seeing them in late July and early August, so we're pretty much on the same track. The larval ticks are rarely infected. There is very little, if any, transovarrial passage from the adult through the eggs to the larval ticks. Larvae feed, again, on a wide variety of animals. If they feed on an infected animal, they will molt to the nymph the following spring. The nymph then is infective. It is able to transmit the spirochetes to the next organism that it feeds on. If it's feeding on another animal, it will make that animal infected for the next generation to acquire the spirochete. The nymph, after successfully feeding, will drop off and be that fall's crop of adult ticks. Adults that do not find hosts in the fall will overwinter in the vegetation and leaf litter and become active again the following spring, typically late March throughout May. Unlike any other medically important tick in this area, these ticks will become active almost immediately during any warming trend in the winter. So as we'll see, that there is no real season when people are free of Lyme disease. This slide shows pretty much the same life cycle, but it has a vertical component. And I'm showing it because it's important for us to learn about the questing behavior or host-seeking behavior of ticks when we try to come out with some sort of control techniques. If you start at the left-hand side of the slide, the female lays a batch of eggs, and the first active stage, the larva, quests at ground level, typically in leaf litter of a wooded area. By questing at ground level, this favors the location and feeding upon small animals, typically rodents, and the preferred host is the white-footed mouse. After it feeds on the white-footed mouse, which not only serves as the principal maintenance host, that is the organism from which most ticks acquire blood meal, but it's also the principal reservoir host from which the ticks acquire the actual infection. If the tick feeds on an infected mouse, it will drop off, molt to the nymph stage, and that infection will be carried to the next stage, transstadially. The nymph then also quests at ground level, again favoring location and feeding upon a small rodent, again typically a white-footed mouse, giving it a second opportunity to acquire the infection. It feeds, drops off, molts to the adult stage, which, unlike the subadults, climbs on low-lying vegetation, typically the shrub layer of a forest. This questing behavior, in contrast, favors the location and feeding upon larger animals. And for this reason, when we talk about controlling different stages of the tick, we need to know not only the timing, but where this tick is and what its behavior is. This slide shows the month of onset of Lyme disease cases in New Jersey. I'm sure it's virtually identical to that in New York. We will see 70% of all Lyme disease cases occurring between the months of May and August. I also want to point out, however, that we see Lyme disease cases with month of onset from every month of the year. Here we have the seasonal activity of Ixodes damanni larvae at the top, nymphs in the middle, and adults at the bottom. You'll notice that if you look at the middle graph, you see that nymphal Ixodes damanni are active at the time when the vast majority of transmission occurs. So from an epidemiological point of view, the nymphs are the most important stage in this Lyme disease cycle. If you go to the bottom graph, you'll see that adults are active in October, November, and early December, and again the following spring. The following spring's population are those adult ticks that were unable to find hosts that overwintered. So they're becoming active again. So that the group of ticks seen in April and May on the bottom slide are really remnants of the previous fall's population that were unable to find hosts. Again, the majority of cases are the result of exposure to nymphal ticks, but that clearly those cases with month of onset in the fall and early spring are the result of exposure to adult ticks. So adult ticks are just as capable of transmitting the Lyme disease spirochete. The reason we don't see huge number of cases at that time is that the adults are considerably larger. They may be observed and removed before they've had a chance to feed. There are far fewer people in tick habitats during the fall and early spring. People who are active are generally wearing multiple layers of clothing, further reducing the exposure to ticks. Another important aspect in devising tick control strategies is an understanding of tick habitat. If someone were to ask me what is the ideal tick habitat in coastal plain physiographic regions such as southern New Jersey and Long Island, I would show this slide, and that's why I brought it. We have a a forest that is mixed hardwoods, perhaps with some pine. It has an understory of similar tree species and a very dense shrub layer made up primarily of high bush and low bush blueberries, huckleberries, some mountain laurel, perhaps some bayberry. It's thought that because Ixodes dammoni is very prone to desiccation, that this habitat offers, at least at the micro level, a fairly high humidity. And that's why we believe that we can find most ticks in these kinds of habitats. Well, supposing that there were 100 ticks per square yard, it really wouldn't matter if no one ventures into these areas. But unfortunately, we do. We modify habitats, in this case for recreational purposes, but we do the same thing for home construction and so forth. And it's when we venture into tick habitat like this, we have the greatest risk of transmission. I'd like to go over just some of the more common plant communities that we see in coastal plain physiographic regions and try to give you some idea of which are the most important for the presence of deer ticks. This is a wetlands area. It's pretty obvious you can see water. This is not a very conducive habitat to Ixodes dammoni, and I would expect to find no deer ticks there at all. This is a wooded area, and at first glance you might say, well, this is a very suitable habitat for deer ticks. Well, while it is wooded, I would point out that the shrub layer is virtually absent, and the reason for that is that this too is a wetland. It's a palustrin forested wetland, and that water is at the surface or near the surface during at least part of the year, typically the winter. And it's felt that these ticks cannot survive this flooding, if you will, and I would not expect to find very many ticks there either. In monocultures of pine, it's usually blocks out so much light that the most we see on the forest floor are grasses, and this is not very conducive, again, to the presence of deer ticks. I can't point to you on the slide, but all the way in the middle on the right-hand side, we start to see some woody vegetation. And there's where I would expect to find the bulk of deer ticks in this kind of habitat. Everything I'm saying is in general terms. There are exceptions to every rule. This is a field situation. I would expect to find Dermacentor variabilis there, the American dog tick, sometimes called the wood tick, but very few Ixodes dammoni, if any. As a field tends to move into secondary woody succession, we start to see deer ticks becoming obvious. Lawns are probably the least favorable habitat for deer ticks. If they're found on lawns at all, it's usually in close proximity to the woodland fringe. Again, lawns provide a very hostile environment to deer ticks. They'd be exposed to almost immediate desiccation. A lot of people commonly use insecticides on lawns for grub control and whatever. And for these reasons, ticks are not often found on grassy areas. I use this slide to illustrate another important ecological factor, and that's called the edge effect. In the background, we have a mature deciduous forest. In the foreground, a manicured lawn. It could be someone's backyard, it could be a soccer field, could be a park. In between is a transition zone called an ecotone. And stated briefly, this edge effect means that where you have a transition from one plant community to another, you would expect to find the greatest diversity in animals and the greatest abundance of animals. And this is important in trying to identify if we're going to make some sort of control effort, where do we get the biggest bang for the buck? Where should we concentrate our efforts? So this edge effect is absolutely critical in the biology and the behavior of deer ticks, and is very important designing control strategies. Lyme disease is often called the suburban illness. We believe that approximately 70% of all Lyme disease cases are acquired from exposure to ticks in or near an individual's residence. And I think there are several reasons for this. Back in the 40s and 50s and perhaps early 60s, residential development in wooded areas essentially was done by first coming in and clear-cutting the property. That is, that the trees were logged off and the houses were constructed essentially on remaining open fields. Starting in the 70s and certainly through the 80s, in a lot of these highly endemic areas, at least in New Jersey, the concept of development changed, where municipalities, primarily in rural areas that were experiencing development, the planners and the environmental commissions decided that they wanted the indigenous vegetation maintained. They call it a lot of things. The most common one is maintaining a woodsy lane concept, where that the indigenous vegetation is maintained on the property and in some cases incorporated into the landscape. It's almost to the point where if you want your project through the planning board, you better consider woodsy lane concept. And it looks great, there's no question about it. This particular residential community was built 15 years ago. It was constructed in approximately 80 acres of a mature wooded forest. So each edge was in essence the perimeter of the wooded area. Well, now the developer came in, clear-cut areas for road construction, for driveways, for construction of the houses, perhaps outbuildings and so forth. And really what happened is that they increased dramatically the amount of edge. Also, construction of houses and certain landscaping activities like putting in decks and railroad ties provide harborage and nesting sites for a wide variety of animals, typically chipmunks. In some instances, people will actually incorporate indigenous vegetation as little islands within the property. So not only do you have an increase in edge around the home construction site, but these little islands of ideal tick habitat dispersed throughout the property. People who move out to these areas will invariably, if they don't already have dogs or cats, will bring them along. For reasons that escape me, people will invariably set up bird feeders. Birds are perhaps important in serving as hosts, perhaps a source as a reservoir host, but their primary responsibility in the Lyme disease cycle is bringing infected ticks from one area to the other. These kinds of communities serve as islands of refuge, either on a temporary or permanent basis, as a result of nearby construction or during hunting season. They tend to attract and congregate a number of hosts for the deer ticks in areas that are very close to where people reside. Well, the next question is, now that we have really enhanced the Lyme disease cycle, and I would mention that the top 5 counties in New Jersey that reported the highest number of Lyme disease cases are also the same 5 counties that have shown the greatest amount of residential development. So I think that is a pretty striking correlation. And I think people who move into these rural areas are trying to escape urban blight, and they know cockroaches, but they don't know ticks. And it takes them a while to figure it out. Now I'd like to go through different kinds of control strategies, what's been tried in the past, look at it from its scientific merit as well as its practical merit. The first study that I'm aware of that attempted to reduce deer tick populations was done in an island situation. And the purpose of the study was to try to eliminate what was then thought to be the most important host in the Lyme disease cycle, the white-tailed deer. The study was designed to live trap all deer from an island, move them off the island, and to see how that activity impacted deer tick populations. Well, the researchers found very quickly that it's a lot easier to live trap deer on paper than it is in real life. And they were forced to kill all the deer on the island situation. They followed the deer tick population for 1 year and published a paper and concluded that it really didn't have a major effect on the deer tick population. Well, we can argue that since we know that there's a 2-year life cycle, that the study wasn't continued long enough before publication. I understand now that they have continued to look at this situation and have determined that, yes, indeed, the deer tick population is somewhat reduced but not eliminated. There are obviously many other hosts that play a part in the Lyme disease cycle. Ed tells me there's a place, is it Bethpage State Park, where there haven't been deer for decades, yet there is an active Lyme disease cycle there, and it's thought that raccoons have substituted for deer. So the elimination of one animal per se is really not going to have a major impact, I don't think, on a deer tick population, particularly when you consider the fact that in endemic areas like Shelter Island, we can expect to see 50, 60, 70, 80% of the ticks containing spirochetes. You have to eliminate a very large number. Secondly, from a scientific point of view, any studies that are done in island situations are not immediately transposable to mainland situations. If you eliminated all deer from a particular island, that's fine. Deer, I guess if given the choice, wouldn't swim across, large bodies of water. But if we removed deer from a fairly large municipality, it would be reasonable to expect that deer from outlying areas would quickly move in and replace the deer that were eliminated. So I don't see from a scientific point of view why this has very much merit. Let's look at it from a practical or political point of view. White-tailed deer are a very important game animal. Millions of dollars a year are spent on hunting and so forth. There are large government agencies that relate most of their effort into maintaining and studying deer. I don't think that the strategy of eliminating this important game animal would really fly. I mean, you'd have a situation where animal rights activists and hunters were lobbying for the same thing. So from a practical point of view as well as a scientific point of view, I don't think this is a way to go. I'm not saying that deer management isn't a good thing to do for a lot of other reasons than Lyme disease, but concentrating on the elimination of one animal, in my estimation, won't work. The second strategy might best be termed habitat modification. This slide is not very clear in this light, but it's the result of a controlled burn. There were studies done in the early to mid-60s that utilized controlled burn as well as physical cutting of shrub layer species in a wooded area. These were performed in the fall and did have a major impact on the adult population. My recollection is that 70 or 80% of the deer tick population, again adults, were eliminated by this activity. The following spring, deer tick adults that did not find hosts populations were again quite low, but the following fall, populations were back to normal, meaning that these kinds of activities, while they do have some impact on adult ticks, don't have any impact on the subadult ticks, which are deep in the leaf litter and inactive. A controlled burn is not the same as a forest fire. It's done to eliminate a certain amount of the leaf litter or pine straw, and apparently it is unable to have a major impact on the subadult ticks. I've investigated a control burn that was done for forest management purposes, and I found the control of only about 50% of the adult deer ticks. Ecologists tell me that in a situation like this, control burn or mowing actually stimulates vegetation growth the following year. So it might be a kind of effect that you really don't want to have in future years. I'm not saying that the elimination of vegetation along pathways through hiking trails is not a good idea, but a way from a scientific point of view to try to control deer ticks by doing this, I think is scientifically not acceptable. Again, I like to look at it from a practical point of view. In some places in New Jersey, people will spend upwards of $250,000 for an acre of wooded property. I'm sure in parts of Long Island that those numbers are probably the same. It is unlikely that after spending this money, they will go in and control burn or clear cut their land. Again, practical point of view, this is not, in my estimation, the answer to deer tick control. Where it is done for forestry management purposes, in recreational areas, on military facilities, it will control, to some degree, adult deer ticks. The next series of slides speak to chemical control, and really in two phases. You've undoubtedly heard of Daminex. The objective of Daminex is that Daminex is a product that is a cotton material impregnated with permethrin that's put in cardboard tubes and distributed in white-footed mouse habitat. White-footed mouse being the most important organism, I think, in a disease cycle, at least from a host point of view. Gather this material, bring it back to the nest, and those ticks that are exposed in the nest, either on the mice or in the nest itself, will be killed from contact to this acaricide. This is a very controversial subject. There have been, and are ongoing, probably a half a dozen studies looking at Daminex. The initial studies showed that this material was better than sliced bread. It was phenomenal. It eliminated all the ticks from mice and so on. Other studies, one recently out of Westchester County that was just published last month, said it doesn't work in Westchester County at all. Studies that have been done in New York and New Jersey as a mutual effort have really shown kind of mixed results. Sometimes it works, sometimes it doesn't work. I don't know if you can see these. This is a study that's done at Wildwood State Park by Dr. Bossler, and what we've really have shown here is that there's no statistical significance among free-ranging Ixodes damonii nymphs. Those are the ones that are looking for hosts. It does great in eliminating ticks from mice, but mice do not uniformly collect ticks from their home range. They follow discrete trails. So while they're collecting ticks from these trails, they're not eliminating the majority of ticks that are looking for hosts. So what these data show is that you have the same risk of acquiring exposure to an Ixodes damonii nymph in a Daminex-treated versus untreated area. From that perspective, I can't recommend that this product, it can be used exclusively for reducing the risk of Lyme disease. Perhaps its function is to augment other tick control activities in a more integrated approach. The next series of slides have to do with a study that was conducted in 1985 following an outbreak of Lyme disease in some reservists from all places from Connecticut at a military facility in New Jersey. If you've been paying attention at all, you will remember two important things about the behavior and biology of deer ticks. First, that the adults are active in the fall and again in the following spring, both times of year when deciduous foliage is absent from the shrub layer. There are no leaves. Secondly, that the adults, unlike the subadults, climb on low-lying vegetation of the shrub layer looking for hosts. We felt that acaricide applications made with a high-pressure hydraulic sprayer would work phenomenally. Essentially, these adult ticks are sitting ducks on the edge of the vegetation. This application was made in November, a time of year when most people wouldn't think about trying to control deer ticks. What these data show that after 3 days using Carbaryl or 7, we can control nearly 97% of adult deer ticks, and with diazinon, another general use over-the-counter acaricide, we controlled 100% of the ticks. That is, after 3 days, we were able to find no deer ticks in that one treated site, whereas in the control, in a 60-minute survey, we were able to get 168 adult deer ticks. I think rather dramatic. We followed the study site through the following spring, and as expected, we continued to see control of adult ticks. The reason, obviously, is that if you control the ticks in the fall, there was very few ticks left to overwinter. So, these data are not unanticipated. So one application against the adults in the fall eliminates exposure to adults that fall and the next spring. 1 year later, it was business as usual. The tick population had rebounded. Again, the reason is that we are unable, with this kind of application, hydraulic spray, to have any effect whatsoever on the subadult ticks, the nymphs and the larvae, which are inactive in the leaf litter. So we had to look at other ways to impact the subadult stages. I think there's a role for controlling adult ticks in situations where, say, the military is having maneuvers in the fall and there are deer ticks present, or there's a Girl Scout camp that's having a Thanksgiving jamboree, that targeted applications against adults will reduce dramatically exposure. But to do it on a large-scale term, I think, is inappropriate unless we've identified for certain that deer ticks are present in large numbers. These ticks tend to be clustered in areas. They're not uniformly distributed in nature. So before any of these applications are made, a thorough survey of the area should be made so that we're not applying these chemicals for no apparent reason. Again, considering the edge effect, we feel that an application made along roadways or paths or whatever will eliminate the majority of ticks that are most likely to encounter humans. So we don't have to treat necessarily huge wooded areas as long as we treat those areas where humans are active. Using 4 different compounds, we had results ranging from nearly 84% to 100% control. So these acaricides definitely work. We were concerned about controlling subadult deer ticks. You recognize that they are active during the growing season. The nymphs in May and June, and the larvae July and August. Well, at that time of year, you have foliage throughout the forested area. We felt that the majority of material that would be applied by hydraulic sprayer would be intercepted by the growing vegetation. That material, which got its way down, would really stop at the leaf litter. The way we try to circumvent this obvious treatment problem was to use some of the same materials but use a different formulation. So we went to a granular formulation which is able to physically penetrate the leaf litter, the growing vegetation, and as well the leaf litter. This application is made by using a chest-mounted cyclone seeder. I understand now there are modified mist blowers capable of distributing granules perhaps a little easier. If you haven't used one of these walking through Cat Briar, you haven't lived. In any event, we get fairly good distribution through the growing vegetation. If you look carefully, you can see the small granular material there. The first year of the study, and these sites had statistically equivalent deer tick populations before we started, and we're determining control by looking at subadult ticks removed from mice. Essentially, we used three materials: diazinon chlorpyrifos, which is more commonly known as Dursban, and carbaryl, which is more commonly known as 7. And the results were control of nymphs from 53 to 100% in the case of carbaryl. And that means that within a week of the application, we were unable to find another nymph on mice in that study site for the rest of the season. We made similar applications against larval ticks. The level of control, I can't even read this, 66 to about 75%. I'm not sure that that's high enough for an organism that has such a high rate of infectivity. But again, we are being able to control ticks in wooded habitats by using a granular formulation rather than a liquid formulation. We've been following these study sites now for 2 years. After the first year, we looked at the adult population in the fall and indeed found that we were having significant control of adult ticks as well. Well, when you think back that the nymph population becomes that fall's adult population, it's not surprising that we've eliminated 85 to almost 99% of adult ticks in these treated areas. So from a single application directed at the nymphs, we were able to control very nicely both stages of the deer tick capable of transmitting the Lyme disease spirochete. This is the following spring, and again we see that control of adult ticks continues. So for one application, we almost have a year's worth of control. In 1990, we switched to carbaryl in additional experimentation, primarily because carbaryl was the only product at the time labeled specifically for deer ticks. We see carbaryl at the highest level, same level we used in '89, gave us in this year 89% control. Lesser dosages weren't as effective. Again, carbaryl at differing dosage against the larvae, we were able to control about 60% of the larvae. In my estimation, not enough to have a public health impact. Last year also, we looked at the effectiveness of aerial applications to control adult deer ticks. Those of you who have any experience with the use of hydraulic sprayers know that you need a large amount of water, and that the areas you can control depend on accessibility and really the length of the hydraulic sprayer's hose. Typically it's 100 to 200 feet. We didn't think this was going to work, but we were interested in, again, very specific applications to remote areas. Again, perhaps for eliminating the majority of ticks for recreational activities or military activities. We were indeed able to penetrate, again, we're talking about applications being made in mid-November, able to penetrate the canopy. Most of the leaves are gone. And surprisingly, after 48 hours, we were able to kill 98% of the deer ticks in those treated areas. It varied from thereafter from 88 to 93%. Essentially 95% mortality by a single aerial application. While I will tell you that, in my opinion, we have the tools now to eliminate a vast majority of both deer tick nymphs and deer tick adults. But I will tell you that some of them get through. This is not 100% activity. Therefore, I would urge you, even though you may have your area treated or have somebody treated, to continue the sound public health practices of dressing appropriately, wearing light colored clothing, tucking up pant legs into socks. Augmenting that kind of activity with the use of clothing repellents. Permanent, I believe, we heard earlier from the congressman, is an excellent material, and it should be incorporated when going into known tick-infested areas. And finally, perhaps the most critical is the constant inspection, self-inspection or inspection of children and pets for the prompt removal of deer ticks. As we heard again earlier, deer tick takes an incredibly long time to insert its mouth parts and begin the feeding process, and it's not until later in the feeding process does transmission take place. So therefore, these activities are also absolutely important. Okay, I'll answer any questions that you may have. Yes.
That Carl, you say is otherwise known as 7 on the market?
Yes.
Okay, so, and this is for animals now, it's easy to do. What do I want to do on our property? How about my dogs that I take out for a walk on a leash now? You know, if mine run loose, my dogs, does that bother them? And would it bother grandchildren run around in bare feet? What effect would this have on more like...
One of the things that was important to us in the selection of materials was that we wanted to use acaricides that were EPA labeled, that had a toxicity level such that they could be purchased and used by the general public without benefit of licensing, and that have a relatively low mammalian toxicity. So consequently, these materials that we used are used uniformly by many homeowners for grub control on their lawns, for application to control crickets and earwigs and spiders along the foundation. There's nothing magical about these chemicals. They're used for agriculture by homeowners. The answer to the question about your dogs, 5% carbaryl is common in some flea and tick collars. General rule is that if you're using a liquid, don't let anyone go into the sprayed area until that material has dried. In the case of granular material, that doesn't apply. I wouldn't recommend going around and having your grandchildren pick up the granules and eat them.
Yeah.
But in fact, these work their way into the leaf litter and probably after a couple of days wouldn't even be visible anymore. So,
Groundwater then?
well, again, these materials are registered by the EPA. Inevitably, they've studied this. If groundwater was impacted by carbaryl to any extent, we would have seen it 20 years ago. This is nothing that is new under the sun. And I'm not selling carbaryl or any of the other products. What I'd like to do is see other compounds that perhaps have less effect on non-target organisms. But right now, these are the only materials labeled for deer tick control. And you know, as a public health official, I constantly get called, can't you do something to reduce the tick population? And yes, now we can. We can make these recommendations. All this material will be published in the next month or two. And hopefully it will then become incorporated into the cooperative extension service bulletins and the professional applicators who I believe now will come out and spray any place, anywhere, with anything for the right amount of money, if you call. Hopefully, they'll be able to use this material because it's absolutely critical that you apply these materials at specific points in time and that you use the right formulation depending on the stage you're after. Otherwise, all you're doing is impacting the environment for no reason whatsoever. That's the point I want to get across. Yes?
That's not supposed to be poisonous. My neighbor used it when it first came out. My cat come home, he was frothing at the mouth. It took me, it was over $200, it's in the bag, and I never never did find out exactly what was the matter with it.
All right. The material that is used in Daminex is permethrin. Oddly enough, it is the same material that's used in Permanone. So it has both acaricidal as well as repellent activities. My guess is that while there is some toxicity to the cotton balls, I wouldn't expect cats to go around and eat that.
No, they probably caught the mouse, and they still never found out yet what it was.
My guess is that it wasn't from the Daminex.
But that cat has been around in the neighborhood, they kept for a long time, never had anything like this, and all of a sudden that gets used. It just seemed very strange. He come home crying and...
Yeah, I think it's coincidental, really.
He was a sick cat. But we saved it.
That's good. Keep those mice down.
Yeah, you said it.
Going back to 76, 77, Dr. Bernard came here to work with a big problem. And my question is, and there's been seem a pro and con on it. Can any animal play host? Because at that time, we had examined other animals, like we examined cows, we examined horses, donkeys, deer, and mice, and we had raccoons, and it seemed that ticks were on all of these animals. Now, is it possible that any animal, in your opinion, can play host to the tick?
Yes. I think certain stages are less likely to be found on certain kinds of animals because of their questing behavior. For example, I've never, ever seen an adult Ixodes damini on a mouse, but I've seen larvae and nymphs and adults on raccoons. I think, yes, they can all serve as hosts. Yes, they can get the tick from one stage to the other. What their role is as efficient reservoir hosts has yet to be worked out. I know Dr. Bossler is studying right now raccoons, and what their role is acting not only as maintenance hosts, but also reservoir hosts. And this is a wide area that people haven't really looked at yet, that needs to be evaluated. Yes?
I'm very cynical about some of the results that you have from spraying, because you cannot control the movement of these host animals. On our properties on Shelter Island, I cannot speak for the community, you cannot control the movement of deer, raccoons, feral cats, neighbors lose dogs. We now have a possum on the island. We never had them before. Catch them alive trappers are capturing up island and bringing them over here and releasing them. They want to bring back the fox. We have rabbits. The rabbits are increasing because they have no natural enemies. We have all kinds of bird life, as you pointed out. Now, do you really see ourselves spraying every fall and every spring in order to control the tick? And because these sprays kill every insect in sight, they are non-specific, will kill between 50 and 100 different kinds of insects.
Well, let me answer your question. You got a lot of questions there. First of all, I'm not suggesting that one or two applications is going to rid your island of deer ticks forever. What I'm talking about right now, with the information we have and the studies we've done, I would say that the most effective technique would be to apply granular material first week in June. And that will control not only the nymphs, but also the adults in that area. I'm not advocating treating the entire island, but if you live in an area, your house is in an area surrounded by woods, you can treat your landscape and you can treat a buffer around your woods so that when your children or grandchildren go chase a ball 5 feet into the shrub layer, that there aren't going to be very many ticks there. Your point is well taken about killing non-target organisms. Most of the non-target organisms have multiple generations a year. So if you killed 75% of them, they will rebound. The tick, remember, now is a 2-year life cycle. So that one application is impacting it for a year. The thing about animals coming in and out of the property, yes, they will bring in ticks that'll drop off and then be a problem the following year. Ticks are not intermittent feeders. They will feed to repletion, drop off, not be a threat until they molt to the next stage, which is sometime 9 months to a year later, and that's why you need subsequent applications. If you were trying to control deer ticks by several years applications of adults, remember that the adults are active in November. That's the time that they should be treated, when virtually all other insect life is inactive. We're not able to kill, for example, the immature ticks in a leaf litter, so we probably won't kill very many other things. That would be a better time ecologically to make your applications. This whole thing is a risk-benefit relationship. We're not here to try to tell you that, yes, you must spray. We're saying, here is a tool. If you ask people, I have, my children have had Lyme disease twice. My daughter is in a wheelchair with arthritic problems. My husband's been out of work. He's lost his job. We have $100,000 worth of medical bills. Ask them whether or not they're concerned about non-target organisms. So it all depends on what your situation is. We're not here to sell any of this. Here's a tool. Here's the research on it. If you want to use it, fine. If you don't want to, then don't.
Why not go back to burning like we did years ago? I used to have to help my father burn the fields so often. No. Why not go back to that? We didn't have the problem.
Well, if you're burning fields, that's not the primary habitat of the deer tick. If you're burning wooded situations, we're not finding the level of control that we would get with...
Get all the undergrowth.
Well, yes, you will get some of it. The research, that's been done.
Lord have lightning, it feels, it has these fires all the time, so the new growth keeps coming up. In other words, you don't have it. The trees are dying, and that's it. So they don't have any new trees to take their place.
Well,
You know what that is.
right, I'm not arguing against that. What I'm saying is that,
Burning is the cheapest and the easiest. Nobody's going to get poisoned by it.
but nobody's going to do that in their, on their residential property.
Then we had to go get your neighbors, and everybody flocked together and did it with bags, with a pail of water and a broom, and that's the way we went around and did it.
In New Jersey, at least, there is very specific laws against burning. You can't even burn your leaves.
I know, that's the
So-
trouble. Laws have changed, and that's why we're having more problems again. I remember I seen so much fire when I used to sit in the chair at night when I was other smoking, you'd see the flames in front of you. If you were out there,
Let me just jump in. As it turns out, in townships in New York State under 20,000 population, which Shelter Island is, you can burn. So that is certainly one of the
That was
options that's
the
being
year.
reviewed.
Yeah.
But as the gentleman points out, certainly he's explained to us the experiences that they've had in New Jersey in terms of their attempt to control the epidemic. Obviously, we can all learn from each other.
That's why Shelter Island's unique. And if we've got so many ticks, why not go back to what we used to do?
The only thing I would add there is controlled burning is not without impact on non-target organisms either.
And I heard the birds that time of the year or anything, when we burn a certain time.
Anyone else?
How could you burn landscaping? I mean,
You can't.
That's it.
Well, that part you wouldn't, but there's a lot of fields that's grown up. We used to have hay. Now, let's go into that, Regina.
Yes.
One thing I'd like to point out that I think you do have to keep in mind here, especially on Shelter Island or areas where deer ticks are really severe, is the key word that you're using is control, it's not total eradication. And I think if you're living on an island or in a rural area, you're going to have to cope with ticks. And there's no magic, and the chemicals and anything in that is going to eliminate every tick. And you can't be fooled into thinking because you use carbaryl or pyrethroid or something else, that you can be totally safe. And that's not going to happen.
I agree with you. That's why I ended the presentation on continuing to use the normal prevention. Yes, sir.
Are there any natural predators for the tick?
That's an area that hasn't really been looked at. There's apparently a parasitic wasp that is in some of the offshore islands of Massachusetts that's able to parasitize perhaps well, let me answer the one thing first. Okay, is apparently able to parasitize about 25% of the nymphal ticks. I would point out that those islands are used by the Harvard Research Group because they have such high tick populations. So, when you think about it, to maintain the population from one year to another, only 2 offspring have to make it through. So if they kill 25%, that's fine. Biological control typically is not very effective in reducing a population to such a point where it has an impact on public health. And these, again, are island situations, not immediately transposable to mainland situations. It needs to be looked at. Guinea hens, I don't know. Christy Brinkley says they will work. That's good enough for me. No, I don't know.
I think birds eat them.
I think a lot of things eat them, but I don't think any one organism is going to have such a major impact to reduce the population the way we need to. Oh, I'm sorry.
Hi. What I wanted to find out is, it seems as if we could get the infection out of the host, like the deer and whatnot, that the ticks would clear the cells within 2 years anyway, since they don't pass it on to the eggs. Is that correct? I mean, if the host didn't have it, if the deer and the raccoons didn't have it, ticks would
Yes,
be a problem.
In theory, if you were able to eliminate the infection from all hosts that Ixodes damani uses, that would scientifically make sense. But that seems to me to be an awful lot to ask.
And these hosts, they stay infected and able to transmit it to ticks all the time, right? They're spirochetic most of the time?
Those that are infected, yes, and like mice, they don't last too long, and you constantly have, even if the virulence is reduced, they're getting infected constantly. I mean, each mouse that I would collect would have, from a half a dozen to perhaps 30 or 40 ticks feeding on it.
So it constantly has bacteria in its bloodstream.
Right,
And that's what constantly gets into the tick.
absolutely.
So is there any way to control the bacteria in the animal?
Well, I know there's some proposed studies to use antibiotic material in mouse chow or salt licks, but we also have laws in animals that we use for game animals or livestock. Those materials have to cease being used 3 months or 45 days prior to consumption. So we have a problem with that. If we have all these deer, yes, they're free of spirochetes, yet they're not going to be harvested because no one can eat them. So this is a very complicated issue. And
one of the questions is, below the star, do they have the same cycle? As it turns out, we're finding more ticks. The way that they're being handled for the deer tick here, would it work for Scapularis and would it work for the Pacificus?
well, Pacificus feeds on a whole different set of hosts. On lizards, I think, is a primary host. So
I think it's the rat. On ladies.
yeah. As far as
Yeah.
that, I can't comment on because I haven't studied that. As far as amblyoma goes, I'm convinced that they are a secondary vector in areas where they're present. One of the reasons I believe that, in addition to finding spirochetes and having them taken off of a site, ECM, is that both nymphs and adults occur at the same time as nymphal Ixodes damani in the same habitat. The only reason we don't see amblyoma acting as such a major vector is because all active stages climb on low-lying vegetation, so they infrequently encounter white-footed mice, and then they're not getting the infection. And also, it may be that their gut microflora is different and that the spirochetes either not able to complete a life cycle or go from one stage to the next.
Do they have a 2-year life cycle? Do they follow the same thing and will carbonell and the rest may kill them? Are you going to kill off all the things that might transmit it?
We have probably had an impact on amblyoma, but in situations where we don't find any deer ticks anymore, there's still plenty of amblyoma there. I think you'd have to go to a change in tactics, that perhaps sprays might be better against them because they are on the low-lying vegetation, not deep in the leaf litter.
So if you nuke all the deer ticks, it doesn't mean you nuke all the ticks that might potentially transmit Lyme disease.
No, but you get the majority of the job done. I don't think amblyoma is quite that important. Yes, sir.
What is the evidence that cumulative effects or dose effects of these sprays is not toxic?
In what? Humans? Well, again, I'm assuming
It's starting to be done.
I'm assuming that there have been numerous studies done on each of these compounds in order for them to get registered by the EPA. Chemical companies complain that they spend, 6 to 8 to 10 years getting a product registered. Carbaryl has been around for decades, and I'm sure has been studied extensively. As far as us conducting any studies on this, I haven't done any. So, yes?
There are environmental groups that have been lobbying for as long as Carbaryl has been around to take it off the market because it ecologically hangs around in the environment without breaking down for such a long time.
Well-
It does seem to be around.
Well, that's not true. Carbaryl has a half-life of about 2 weeks. So every 2 weeks, whatever dosage there is half of what it used to be. I mean, these compounds were designed to replace persistent materials like DDT. If we applied DDT granular to the wooded areas, we wouldn't see a tick for a long time. Again, I understand what you're saying, and I'm not advocating one way or the other. I'm saying here's a tool. If you want to use it, fine. Anyone else? Thank you.
I would just like to make one comment. Thank you, Terry. That through the use of acariciidal measures like Terry has just explained, those of us that are public health officials must have these in our arsenal to combat things quickly. For example, we have the threat of mosquito-borne encephalitis constantly on the east end of Long Island. Fortunately, the surveillance indicates most of the times that we don't have to do anything, but we certainly have to have the chemicals in our arsenal to hit quickly, and by spraying by aircraft if necessary, because these things can spread very rapidly. We also want these available for the ticks. So we're not pushing the compound. Cornell has their recommendations. They're pretty much the same as what Terry just went over. I just looked at them. So these are allegedly the safest available and will do the job. And they're just available there in the arsenal, and that's the way we're looking at it. We don't actually partake in any spraying ourselves. So with that, I think you have announcements, Tom?
I mentioned the gold stain test earlier, the Rocky Mountain Lab test. Tomorrow morning, Dr. Burriscano is going to give the talk in place of Dr. Berger. He participated in some of the clinical studies on that test, and we'll be presenting some information on that. He also has some information on females and Lyme disease, which is very interesting. And what we'd like to do is invite you all back for that talk if you'd like. We'd also appreciate it if you tell your neighbors and friends about what we're presenting here and the kind of information that you're getting. And this is being taped for community television, so you'll be able to see it again on community television very shortly. And also let your congressman know what you think about what's going on, too. I'm sure you're very interested.
The luncheon is across the hall. I imagine the same room as where the break was held.
And it's included in the
And it's included with your registration fee.